In this video, we're going to talk about something called polar coordinates. What we are used to is working with what we call rectangular coordinates. So the rectangular coordinate system is that grid with the squares or those rectangles. And where the ordered pairs that we work with are x comma y, where the first number tells us how much to go left or right in that rectangular coordinate system, and the second number tells us how much to go up or down in that rectangular coordinate system. So if we were to plot the point 4 comma 1, we know that we would always start at the origin, so we'd start at 0, 0. We would go 4 units to the right and then 1 up, and that's how we would plot our point in that rectangular coordinate system. So now we're going to work with what we call the polar coordinate system. So the polar coordinates work a little differently. So you'll notice that our graph paper here is actually a bunch of circles. These are what we call concentric circles, meaning they all have exactly the same center. The very center of all of those circles has a name. We call that the pole. So the pole is the point at the very center, and it's sort of in the same place like you would think of as the origin. This line right here, in the positive x direction, would be called the polar axis. So the polar axis is very similar to the idea of that positive x-axis in our rectangular coordinate system. So we have a bunch of circles, and all these circles are different sizes. So the first circle we have labeled as 1 unit away from the pole, and then 2 units away from the pole. In a way, you can think about these labels as being the radius of the circle. So the radius of a circle would be starting at the center and then going to one side of the circle. That length is what we would call the radius. Also, we have lines marking the degree measure along the circle. So if I start at the positive x-axis and I go in that positive angle direction, these lines that I have here will mark off each one of these angle measures. So we're going to talk about here plotting points that are considered polar coordinates. When we do the ordered pairs for polar coordinates, the first number that you're going to see is what we call r. R is the distance that the point is from the pole. So how far away? Now what that really means is, what circle will I plot this point on? Will I plot that point on circle 1? Will I plot that point on circle 2? And so on. All right, so the second number that's listed is going to be our angle theta. So this is the angle. And it's always measured from the polar axis. And remember, the polar axis is basically exactly the same thing as that positive x-axis that we talked about in that rectangular coordinate system. Alright, so let's plot a few points. I've got some points from A to H here, and I want to remind you that these ordered pairs, the first number is the r value, the second number listed is that angle measure. Alright, so I'm going to plot point A. So plotting point A, the first number I see is a 5. So that tells me that I'm going to be somewhere on circle 5. So I'm going to be 5 units away from the center of that graph. So somewhere on circle 5. But I'm supposed to plot this point at the angle measure of 120 degrees measured from the positive x-axis. So that actually puts me right here on circle 5 at the 120 degree mark. So I have to be on circle 5 and I have to be at the 120 degree mark. So that is the location of point A. So I'm going to label that A to describe that location. So that's on circle 5, 5 units away from the pole, but in the direction of 120 degrees measured with the positive x-axis. Alright, so let's look at point B. Point B, we have 6, 180 degrees. The first number listed tells me how far away to move from the pole. Essentially, we're talking about being on circle 6. So somewhere here on circle 6. Okay. And then we're supposed to go in the direction of 180 degrees. So I'm 180 degrees on circle 6. So 1, 2, 3, 4, 5, 6, 6 units away from the pole in the direction of 180 degrees, measured starting at the positive x-axis, or the polar axis. So that would be the location of point B. Okay, let's talk about point C. Now point C, a little different there, because the angle we're given is a negative angle. Still measured from the positive x-axis, or in other words from the polar axis. So we're going to be on circle 7. So I'm going to be somewhere on the outer circle 7. But I'm supposed to start at the polar axis and move in the negative direction 30 degrees. So if I do that, that puts me right here, right? 30 degrees from that polar axis measured in that negative direction would put me here on circle 7. So that's going to be the location of point C. Okay, let's look at point D. Point D, we have 3, negative 90 degrees. So we're going to be somewhere on circle 3. So somewhere on circle 3, 3 units away from the center. So 3 units away from the pole. Okay, but what's the direction that I'm going to plot this point? Well, it tells me to start at the polar axis, or at that positive x-axis, and then move 90 degrees in the negative direction until I get to circle 3. So that's going to be right here. So on circle 3, I went negative 90 degrees. So in the negative direction, 90 degrees, that puts me right here. So that would be point D right there on circle 3. Okay, I want us to pay close attention to these last 4 points. Okay, so this is going to come up again later. Point E. So that's R value of 4, so that's on circle 4, so I know I'm going to be somewhere on circle 4, I just don't know which direction I'm going to plot that point. The angle measure I'm given is 0 degrees. So that is going to be right here at the 0 degree mark and also on circle 4. So that would be point E. And erase some of my lines here. Remember, all of these are just one point. It's always just one point. They're not lines. The lines can help us, but each one of these is just one point plotted on our graph. Okay, let's look at point F. Okay, so point F says the R value is 0. If the R value is 0, that means I'm going to move 0 units away from the pole. So if I'm at the pole, and I don't move anywhere away from the pole, so go 0 units away from the pole, then I'm staying at the pole. It does not matter what the angle measure is. So stand at the pole, don't move away from the pole in the direction of 30 degrees. Well, if you're not going to move away from the pole any distance, because your R value is 0, then you're going to stay right there at the pole. The angle measure is irrelevant. So this is actually a point that's plotted at the pole. Okay, it doesn't matter if you're supposed to, stand in the direction of 30 degrees. If you're at the pole, you're at the pole. So that's point F. Okay, let's look at point G. Point G is 0, 240 degrees. So we're supposed to plot this point 0 units away from the pole. So starting at the pole, go 0 units away. Okay, well then I'm still going to be standing at the pole. It doesn't matter if I'm facing maybe in the direction of 240 degrees. I'm still standing and plotting that point at the pole because the R value is 0. Okay, if the R value of a point is 0, it does not matter what the angle theta is. It does not matter. This point with an R value of 0 will always be plotted at the pole. The angle could be 30 degrees, it could be 240, it doesn't matter. Now, it could also be that the angle that you're given is 0 degrees. But if the R value is 0, then you're not supposed to move away from the pole at all. So you start at the pole, move 0 units away from the pole, so stay at the pole, and face in the direction of 0 degrees. Well, it doesn't matter which direction you face, the point is still standing at the pole. So all of those last 3 points are plotted right at the very center at the pole. Now, if your R value is negative, things get a little more interesting. If your R value is negative, then the point is plotted 180 degrees on the opposite side of the circle from the given angle. So it's not plotted at the angle you see, but an angle that is plus or minus 180 degrees away from the given angle. Alright, so when we are given negative r comma theta, then the point is actually plotted at positive r comma plus or minus 180 degrees of the given angle. So let's see what we mean by this. Okay, so let's look at point A. Point A, we have negative 4 comma 210. Where this point actually gets plotted, it's going to be plotted at a positive 4 comma, we're going to subtract 180 degrees from the given angle. So that's actually plotted at 30 degrees. So we're actually going to plot that point at circle 4 at 30 degrees. So you want to keep something in mind here. If your r value is theta, you have to be a little bit more careful about how you plot your point. You're going to add or subtract 180 from the given angle, change the r value to be positive, and that's where we plot the point. You'll notice something also, that if you did go to positive 4 comma 210, so if you went back there and plotted the point there, it would be 180 degrees on the opposite side of the circle from where you needed to be. So if I plotted my point here, right, I would be along that straight line. I would have to go backwards along that straight line to actually plot the point. All right, so the point is not plotted at 210 on circle 4. Because the r value is negative, you need to change your angle first, convert your r value to be positive, and then plot the point there. So it is not plotted here at that green dot. It is only plotted at one location, and that is actually the location of point A, that red dot right there. Okay, so it's a little different. If your r value is negative, things get a little weird. Okay, let's look at point B. Our r value is negative, so we have negative 6 comma 180 degrees. So where we're actually going to plot this point is change our r value to be positive and then subtract 180 degrees. Now you might say, well, how do we know to add or subtract? Well, typically what we like to keep our angle is in between 0 and 360 degrees. Okay, so typically we include the 0. So typically we include the 0, but we do not include 360. Okay, so that's typically what I'm going to err for. So one question that you might ask yourself is, okay, you said we can add or subtract 180 from the angle that we see to actually come up with a new point to plot. How do I know whether to add or subtract? Now what I do is I typically add or subtract to keep my angle in between 0 and 360. And typically we include 0, but we do not include 360. Now, so officially it doesn't matter if you add or subtract. The point will still be plotted in the right location. However, if I had taken 210 degrees and I added 180, right, that would give me 390. 390 would be plotted still in the same location. So I would start it at the positive x-axis and go all the way around the circle 360 degrees, and then I'd have to go 30 degrees more. So I would still plot the point there. But getting an angle that's above 360 makes things just a little more complicated than they need to be. So what I do is I typically add or subtract 360. I do whichever one will keep my angle between 0 and 360. But like I said, officially it doesn't matter. This would still be plotted in the same location. So you can add or subtract. I am going to add or subtract depending upon what would keep my angle in between 0 and 360. Okay, so when we come to point B, that's a negative 6. Since my r value is negative, I'm going to rewrite this point first. I'm going to plot this point at positive 6, comma. Now here I can add or subtract 180. It doesn't matter. But if I add 180, I get 360. Okay, so I'm just going to subtract 180. It really doesn't matter. The point will be plotted in the same location whether you add or subtract. But if I subtract 180, I get 0 degrees. So this point B is actually going to be plotted on circle 6 in the 0 degree direction. So this point is plotted right there. So there's my point B. Okay, so once again, if you were to have plotted your point at 6, 180, so if you were to plot your point here, that would be incorrect. You'd be 180 degrees in the wrong direction. If your R value is negative, you do not plot the point at the angle you see. You add or subtract 180 from that angle measure, write the new point, and plot that point there. Okay, so this would be incorrect. You would have to go back along that straight line and actually plot that point where that green dot is at point B. Okay, let's look at point C. Point C also has a negative R value, so -7, -30 degrees. So I can add or subtract 180 from that 30-degree measure. Since it's negative, if I subtract, that's just going to get me more negative. And that sometimes is hard to plot. So if I have a choice, I'm going to go ahead and try to keep my angle positive, so I'm going to add 180 in this case. So I'm going to plot the point at +7, what is 180 degrees minus 30 degrees? That gives me a positive 150. So I'm actually going to plot that point at the 150 degree mark on circle 7. Okay, so that's point C. Okay, point D, we have -3, -90 degrees. Since the R value is negative, I'm going to rewrite this point as a positive R, and I'm going to add 180 degrees. Now remember, you can add or subtract, it doesn't matter, but do the one that makes things easier. -90 plus 180 is going to keep my angle positive. It's just going to be easier to work with. 3, 90 degrees. So that's on circle 3 in the direction of 90 degrees. So I'm going to plot my point right there. So that is point D. Okay, point E, I have -4, 0 degrees. So I'm still interested in working with that negative R value and changing it to a positive R value. So we're going to convert -4 to +4, and I'm going to add or subtract 180. So in this case, I think adding 180 would be easier, keeps my angle positive. 0 plus 180 is 180 degrees. So I'm actually going to plot this point on circle 4 at the 180 degree mark. Okay, and there's my point E. All right, point F, we have -3, +30 degrees. Since my R value is negative, I'm going to rewrite the point. That's a +3, add or subtract 180. So here I'm going to keep things positive by adding 180. 30 plus 180 is 210 degrees. So we're going to plot point F on circle 3 at the 210 degree mark. Okay, so there we are. So there's my point F. Okay, so on circle 3, 210 degree mark. All right, point G, we have -5, 240 degrees. Since my R value is negative, I'm going to rewrite the point. It's going to be officially plotted at a +5, Now here, would you like to add or subtract? Okay, so let's see. If I add, I get a pretty big number, right? I get 400, it looks like 420. Okay, so I don't want to plot an angle measure of 420. That's kind of too big. Takes a little more work. So instead of adding 180, I'm going to choose to subtract 180. So you can choose whichever one you want. All right, so I'm choosing to subtract 180. So that's 240 minus 180. That gives me a +60 degrees. So I'm going to plot this point at 5, 60 degrees. So on circle 5 at the 60 degree angle mark. So I'm actually going to plot that point right there, and that's point G. All right, lastly, we're going to look at point H. I have -8, 120 degrees. Since the R value is negative, we are going to rewrite the point. So that's +8, Now would you like to add or subtract 180 degrees from 120? If I subtract, I will get a negative answer, so let's add. So I'm going to add 180, and that gives me 300 degrees. So point H, we're going to be on circle 8, which is the very outer circle, at the 300-degree mark. So that right there is point H. So as you've seen, we have positive R values, we have negative R values. We work with positive angles, and we've also worked with negative angles. So there's many different ways of representing these polar coordinates. We've also seen that there are two representations of the same point that are possible. So for point A, we were given this point with a negative R value. We rewrote the point and then we plotted it. But these 2 points are actually given exactly the same location, A. So if I was given this point, I would plot it at A. If I was given this point, I would plot it at A. Those are basically 2 different names for exactly the same location. So 2 different names for exactly the same location is what we have for each of these points. Okay, so we call these equivalent expressions. So these are equivalent expressions for the same point. I want to focus on point A. So I'm going to erase all of the other points for the moment. So I'm going to erase everything except for point A. And let's give 3 different equivalent expressions for -4, 210 degrees. So what are some different ways that we could represent the point that would be plotted in exactly the same location as A? Alright, so before we start doing that, I want to give 4 different categories that we're interested in and 4 different ways of representing that same point. So one of those ways is for R to be greater than 0. In other words, that means R is larger than 0, so positive. So that means a positive R value. And we can have 2 points where R is positive. We're going to have 2 points where R is negative. So R less than 0 means R is negative. So this means R is positive. And then we're going to have 2 points where the R value is negative. Okay, we're going to combine each of those positive R values with a positive angle and a negative angle. So a positive angle would be an angle between 0 and 360. Equal to 0 but not equal to 360. So this would be a positive angle. So we're going to have a positive R and a positive angle. And then we're going to have an R value that's positive, but combine that with a negative angle measure. So to say that our theta is negative, we're going to put it between -360 and 0. So in this case, the angle has to be in between those two, 0 being the largest. This is how we represent a negative angle. Okay, and if our R value is negative, we're going to pair that up with exactly the same things. Okay, so we're going to have 2 points that have a negative R value and a positive angle measure. And then an R value that's negative along with a negative angle measure. Once again, including 0 but not including 360. Alright, so what category does the given point fit into? So this is the point we're given. Which of these 4 categories does this point fit into? It has a negative R value and it has a positive angle. So that representation is going to fit into this category here. It has a negative R value and a positive angle. So I'm going to write that right beside that category. So that's -4, positive 210. So that fits there. Alright, so we want 3 different representations that fit into these other 3 categories that are left. Alright, so let's go for the positive angle and the positive R value. The positive angle and the positive R value is something we've actually already found up here. The easiest representation of that point would be circle 4 at the 30-degree angle mark. And that's what we actually used to plot that point originally. So we actually already have that representation. Positive R value and positive angle is usually the easiest representation for any polar coordinate. So this category is fulfilled by that point there. So now we need to fill in these other two categories. Now both of these say that we have to have a negative angle. We need a positive R value combined with a negative angle, and a negative R value combined with a negative angle. So let's see if we can come up with those other representations. Alright, so let's start with a positive R value. So the R value, of course, has to be 4, because we have to stay on circle 4. But what's a negative angle way of getting to that exact same location? So if I start at the polar axis, and I rotate in the negative direction, I'm going to go all the way around until I get to point A. Okay, so then I'm going to stop at the same location of positive 30. So essentially what I want for that is a negative coterminal angle. So I want an angle that's in the same location, but that is negative, so that's the definition of a negative coterminal angle. How do I find a negative coterminal angle to a positive 30 degrees? Well, we're going to subtract 360. What is 30 minus 360? That gives me negative 330 degrees. Right, so now I have another category filled in. Positive R value, negative angle theta. Now, if you were to plot that point from scratch, right, I would know that I was on circle 4. So I'm somewhere on circle 4, and I know that the given angle will be measured from the positive x-axis and then rotating, though, in that negative direction. Plotting my point right there at negative 330 degrees. Right, so if you're not sure if that's an equivalent representation of that same location, try to plot that point from scratch and make sure you land at exactly that same point A. Okay, the last one here, we need a negative R value and a negative angle, and that's the trickiest one. Okay, we need a negative R value and a negative angle. So for that, what I recommend that you do is you go to the angle that's also has a negative R value. We know the R value is going to be a negative 4 because we have to be on circle 4. The trick for this one is to go to the 210 degree mark. Remember, that's on the opposite side of the circle. So I would go back to the 210 degree mark, the other ordered pair that has a negative R value, and look at that angle. Okay. What we want then is a negative coterminal to this angle. So a negative coterminal angle to this angle. So how do I find a negative coterminal angle to 210? Well, we're going to subtract 360 again. Right, and that gives me negative 150 degrees. Alright, and if you're not sure about that, you can always start from scratch. Let's see if that would make sense. So if I asked you to plot the point negative 4, negative 150 degrees, what would you do? Well, you would convert that point, right? You would say, well, that would be positive 4, add 180 degrees, and that would be 30. Right. All right, so there's our last category. We found an ordered pair for that. So a couple of things before we walk away from our 4 categories and our 4 points is that these two angles, so when you have your positive R values, you have a positive angle and a negative angle, these two angles are always coterminal. So if you start with the ordered pair that has a positive R value and a positive theta, to get to this value you would just subtract 360 from that positive angle, and then you get a negative coterminal angle also with a positive R value. To get to these two, the green and the yellow, to get to those two angles with a negative R value, you can start with the original positive angle with that positive R value, and to find these you can add 180 and then you can subtract 180 from that 30 degree angle. So if I add 180 I get 210, if I subtract 180 I get negative 150, and I can combine those two angles with that negative R value. Okay, so you can kind of base everything off of that positive R, positive angle, ordered pair, subtract 360 to get the second one with the positive R value, add or subtract 180 to get to those negative R value equivalent expressions. All right, for example 3, we're asked to plot the point 5 comma negative pi over 3, and then we're going to give 3 equivalent expressions for that single point. So 5 comma negative pi over 3, our angle is given to us in radians. So remember that's r comma theta. That angle is given in radians in this case. And how do we know that it's in radians? You can make the assumption that the angle that you're given is in radians if there is no degree symbol. And in fact, if there is no degree symbol, you must assume radians. Okay? So if there's no degree symbol in that second value, then we assume radians. So negative pi over 3, what is that? So let's convert to degrees. It's easier for us, I think, to work in terms of degrees. So let's go ahead and convert to degrees. So remember that when you convert from radians to degrees, that pi is equivalent to 180 degrees. So what I'm going to do in this case is I'm going to come up to my point, and I'm going to substitute, in place of pi, I'm going to substitute pi with its equivalent in degrees, 180. So that gives me negative 60 degrees. It's a really easy way to convert from radians to degrees. So that's actually a pretty easy point to plot when I think about it in terms of degrees. So that's on circle 5, and then at the negative 60 degree mark, which is right here. So if I go negative 60 degrees, starting at that positive x-axis, rotate here, that's negative 60 degrees, plot my point. All right, so we plotted that point. Now what we're asked to do is come up with 3 equivalent expressions for that same point. Okay, so I'm going to do a couple of things here. First of all, I'm going to write down the point that we just plotted. And when you are presented with your original polar coordinate in terms of radians, then your answer should be given in the end in terms of radians. So I'm going to make sure that my final answer is converted back to radians. So that point is 5 comma negative pi over 3. What's another way of representing this angle? Let's say that I have a positive r value again. And let's think about it degrees, and then we'll convert it to radians. So what's another way that I could get to this exact same location? Well, I can start at the positive x-axis and rotate positive angle direction to get to a positive 300 degrees. Okay, what's the radian equivalent to 300 degrees? Well, that's from my unit circle. I know that's 5 pi over 3. All right, and those angles are coterminal angles. They're 360 degrees apart. Okay, now we also want to come up with 2 equivalent expressions with negative r values. So we want a positive angle and a negative angle to accompany those negative r values. Okay, now how do we do that? Take one of those angles here, and you think about adding or subtracting 180 to those. So if I add or subtract 180 to the angles that I have here, I'm going to get 180 degrees to the opposite side of the circle. So let's take 300 degrees and subtract 180. I get 120 degrees. So one of those angles is 120 degrees. All right, now, how do I get this angle? The angles that are on the negative r values, those angles are going to be coterminal angles. So I want a positive angle and I want a negative angle to accompany that negative r value. These 2 angles are always coterminal. So I'm going to go to the 120, and I'm going to take that and I'm going to subtract 360. So that gives me, what, negative 240? Okay, so once I find those angles that accompany the negative r values, I want to make sure that in the end, if I started in radians, I want to end in radians. So let's convert these back to radians. Okay, so what is 120 degrees in terms of radians? And we actually know that straight from our unit circle, right? That's 2 pi over 3. What about 240 degrees? 240 degrees, we know that from our unit circle. In radians, that's 4 pi over 3. And I'm just going to put a negative sign in front of that. Okay, so now we have our 4 categories. So let's think about those categories. I have an R value that's positive with an angle that is negative, so a negative theta. I have an R value that's positive with a theta that's also positive. We wanted R values that are negative, so 2 points that have negative R values with a positive angle measure and then also a negative angle measure. So we have met all 4 categories with positive R's, and positive angles and negative angles. Alright, for example 4, we're asked to plot the point -6, negative pi over 4, and then we're asked to give 3 equivalent expressions for the point. Okay, so I'm going to think about this in terms of degrees. We talked about a shortcut that pi is equivalent to 180 degrees in radians. I'm going to even go a little bit further than this and say if I divide both sides here by 4, pi divided by 4 we know is equal to 45 degrees, and we know that from our unit circle. So really what I'm working with here is -5 times 45 degrees. Put that into my calculator, I get -225. So I would like to plot this point. Now before I plot this point, I realize that I have an R value that's negative. And if I have an R value that's negative, we know that we're going to change the R value to be positive and add 180. So that actually gives me -45 degrees. That point is going to be a lot easier to think through and a lot easier to plot. I know it's on circle 6, and I know it's at the -45 degree point. So I'm going to start at the positive x-axis and rotate 45 degrees in that negative direction. Okay, and so there's where my point gets plotted. Alright, now that I've plotted the point like we wanted, let's find 3 equivalent expressions to the given point. Alright, so remember our 4 categories. We want an R value that is positive, and we want an R value that's negative. We want 4 different points. Okay, we want to accompany that with a positive angle and then a negative angle, and then a positive angle and then a negative angle. So we want all 4 categories to be filled. And remember, we could think in terms of degrees, but then we want to convert our final answer to radians because the original problem was given to us in radians. So the point we just plotted, -6, -225, that was the original point that we were given. Let's put that into a category. That's a negative R value and a negative angle. So that's down here. I'm going to go ahead and write that in terms of radians. Okay, so that category is already taken care of. Now we need to come up with the other 3 equivalent expressions that represents that exact same point that we've already plotted. Now we actually converted it, as we plotted it, we converted it to a different equivalent expression. Here we have a positive R value and we have a negative angle theta. Now we just need to convert it to radians. So positive R, negative theta, that's here. 6, and what is -45 degrees in terms of radians? Well, 45 degrees is pi over 4. We'll just put a negative in front of it. So now we already have 2 equivalent expressions. Alright, let's do the easiest one. That's a positive R value and a positive angle. So if I start at the positive x-axis and I rotate all the way around in the positive direction until I get to that point, that's 315 degrees. But what is that in terms of radians? Right? So we know that that is 7 pi over 4. We know that from our unit circle. So we have all 3 categories except for this one. We need R value that's negative and a theta value that's positive. So we know it's going to be a -6, comma. So one thing we know is that these 2 angles that both have the negative R values are supposed to be coterminal. Let's go back to the degree measure equivalent for that angle. How do I find a coterminal angle to -225? Okay, well, to find coterminal angles, we add or subtract 360. We want a positive angle here, so I'm going to add 360. Okay, so that gives me a positive 135 degrees. Okay, so that's the angle that I want here. Now, what is 135 degrees in terms of radian measures? So we know from our unit circle that would be 3 pi over 4. Okay, so now we have found all three equivalent expressions to the original polar coordinate that we were given.